Hi, you're welcome to another modern infrastructure video, and today we're talking about IAC recommended practices. In the first video of this series, which will be linked in the description, we introduced Zephyr, which is a fictional company that uses Pulumi to manage its online retail store. That video discussed how to organize your code and also discussed about Pulumi stacks. And in this video, we're going to be answering two questions users frequently ask when they're working with Pulumi in teams. The first question is, how can I best enable multiple developers to collaborate on a Pulumi project? And the second question is, how can I use Git and Git branching to support this kind of collaboration? In this video, we'll provide some guidance and recommended practices around these topics using Zephyr and its online store as the use case. Let's do a little bit of catch up with the Zephyr team. When we last met up with them, they were off and running and they were managing their newly refactored online store with Pulumi projects, and they used two Pulumi stacks, one for development and the other one for production. Up till now, the two-stack approach has worked well for the team, and it allowed them to focus on building new features, integrating those features into the shared environment by developing and testing locally, and then merging everything into their main branch and going from there straight up into production. Typically, when the Zephyr team wants to work on a change, they deploy them first into the dev environment, and if everything goes well, it will build a new container image for any service whose code has changed since the last stack update, and it will push those images to Amazon ECR and update the EKS cluster to deploy the services automatically. When the new features are ready for customers, a team lead will deploy the main branch to production manually. So they've been doing this for a while and it's been working for them. But I also like to share a few details worth noting about Zephyr's current setup. Some of the things to note about their setup: both of their stack configuration files, which is the pulumi.dev YAML and the pulumi.prod YAML, are checked into version control. This is safe and considered good practice because it allows the team to review or change the configuration of a given stack easily by viewing or editing the code in each file. The main branch is the only long-lived branch in the repo. All other feature branches are deleted once they get merged into main. Thanks to this workflow, the application deployed to the dev environment tracks closely with the latest code in main. As such, the dev branch serves as like a kind of pre-production or integration environment that not only allows the team to dog food and test new features as they're added, but also allows them to catch bug and other regressions before they escape into production. When things go wrong, the team can review the list of recent stack updates to identify the source of the defects and get it fixed or do a rollback. Zephyr is using the Pulumi service backend with a single organization that everyone on the team belongs to and separate AW accounts for their development and their production environment. Everyone on the team has read-write access to the AWS account used for development, but only the team lead has access to the AWS account used for production. That's why the team lead is the one that goes to deploy the current main branch into production if everything goes well. So basically, life at Zephyr was good until it wasn't. And one day during an active sprint, a developer who had started working on an improvement to the checkout process realized that it might benefit from an updated version of Redis, which appeared to be presently pinned at 6.0 in the Pulumi program. So the developer wanted to change that version from 6.0 to 7.0. After a quick spike to validate the enhancement locally, the developer felt confident that the Redis upgrade was the way to go for the improvement. But since the deployed version of Redis would ultimately dictate the code that have to be written to finish the feature for real, they couldn't really be sure without testing the theory with a full deployment. What they really wanted to do was to be able to deploy a Redis upgrade along with the associated code changes into the AWS environment as much like production as possible without having to go through the process of making a pull request, getting it to be merged, and waiting for the team lead to deploy the dev stack, only to realize later that the code didn't actually work as expected, and then they'll be forced to revert it. In situations like this, it can be tempting to suggest that the developer simply picks up and uses the dev stack, especially on small, fast-moving teams like Zephyr, where everyone already has access to the Pulumi stack and the shared cloud environment. Pulumi makes this sort of thing easy, but it's not typically what would be advised, because you can deploy your local changes to the dev environment. All you need to do is check out your feature branch, select the dev stack, and run a Pulumi up, wait for a few moments, and the changes will be deployed. This approach works, but it presents at least a few problems. The team will lose all of the practical benefits of having the dev stack track closely with their latest content in main, because remember, this particular thing is something they are just trying to test out, so they don't want to merge in a PR they are not even sure is going to work in the first place. And also, the team lead's deployment of main to dev later that day would override the developer's own feature branch deployment. There's a good chance that the lead would notice the diff in the deployment preview and deduce that someone else on the team has deployed something to dev, out of the band. But if they didn't, the developer's ad hoc deployment would be lost. At best, it would force both team members to drop what they were doing and get in touch to figure out what to do next. At worst, it would lead to confusion and the potential for shipping untested code, which could be problematic. Another issue is that it raises the risk of developers overwriting each other's works. Active collaboration on the same stack leads to likelihood of deployment risks. And on the other hand, it's a good thing that Pulumi prevents, same stack updates from running concurrently. So you would get, conflict errors that look like this. So now we need to step back and reassess. We need to ask these questions. And these are the questions that we actually started this video with. The first one is, how can I best enable multiple developers to collaborate on a Pulumi project? And the second one is, how can I use Git and Git branching to support this collaboration? To allow multiple developers to collaborate to a Pulumi project, people should use Pulumi stacks. We've seen a few ways that having multiple developers share a single stack for ad hoc deployment can lead to various problems. But we've also seen at least one solution in where being able to run ad hoc deployments without the risk of colliding with existing environments can be quite valuable. In fact, there are many reasons you might want to do this. Unfortunately, Pulumi makes it quite easy to do so. If you're making very big changes that are like changes to your code and changes to your infrastructure at the same time, you would want to validate that those changes even work before going through the stress of getting pull request approvals, pull request reviews, and merging everything into your main branch. And thankfully, you can test out these things by using what we call Pulumi developer stacks, and it's easy to do that. This is a recommended practice, and it is to allow developers to create and manage their own personal stacks. In this workflow, developers working on a feature branch are able to iterate freely on both application and infrastructure, deploying as often as necessary into a shared cloud environment and destroying the cloud infrastructure when it's no longer needed. So for the developer, the typical workflow would be that they will check out to a new feature branch, they will make changes to their application and their infrastructure code, and they will create their personal developer stack, select their personal developer stack, and deploy their stack to their shared cloud environment using Pulumi up. If everything works out as they iteratively test, then they can commit their code and submit a pull request, and then the pull request can get merged and everything can go from there because everything worked out the way it was supposed to work out. It's better than merging a pull request you're not sure would work and having to revert when it doesn't work. At least in this case, as things don't work when you deploy, you can work iteratively until everything is stable before you now merge your pull request. Benefits of a workflow like this are many. So there are no resource naming collisions because Pulumi names cloud resources uniquely by default. So there are no two stacks that would ever produce cloud resources with the same names as long as they are both being deployed by Pulumi. There are no deployment conflicts as well. When every developer has a stack of their own, they can deploy it to their sandboxed environment as often as necessary without having to wait for another deployment to finish first. So if your team has 5 developers, I am on your team and I am testing out a feature with Pulumi and I'm trying to run my own developer test stack and someone else is trying to run their own developer test stack, there wouldn't be deployment conflicts. So there are no more deployment conflicts in these kinds of situations. And everyone on the team has their own production life environment for them to use for their end-to-end testing. Now we've answered the first question. Let's go to the second question. The second question is, how can I use Git and Git branching to support this collaboration? We've also seen that the Zephyr team's existing Git workflow has worked well for them. And it turns out this workflow also works well when it's combined with the use of developer stacks. So we might as well continue using these developer stacks. For example, after creating and deploying a new stack to validate and test that the proposed Reddit upgrade works, the Zephyr developer included a link to the application in the associated GitHub pull request, and the reviewers were able to follow the link to the online store and see the effects of the shopping carts change firsthand, which meant they were able to approve and get this change merged quickly, and they confidently know that it would work when it's deployed into production without any issues at all. I also want to give this bonus point. If on your team you are going to be using developer stacks, it's important to name your stacks clearly. One thing I would advise is that, your team sticks to some kind of naming convention for stacks, and that generally just helps keep things organized in your entire Pulumi organization. Thanks for watching this video, and I look forward to seeing you in our next Modern Infrastructure Wednesday video. Have a fantastic day. Bye.